In 2015, Netflix faced escalating bandwidth expenses, with streaming costs consuming a significant portion of their $6.78 billion annual revenue. As the platform's global audience expanded, Netflix costs started to spiral high out of control, while their video streaming services spiraled out of control in the opposite direction, creating pressure from both investors and users of the site to fix it before the entire company collapsed under its own success. So they decided to do the most obvious thing: abandon everything. Before 2015, Netflix relied on a static encoding ladder that rigidly applied fixed bitrate resolution pairs, assigning 500 kilobytes per second to 180p streams regardless of content complexity. This system, built on outdated constant bitrate, or CBR, and static variable bitrate, or VBR, techniques, was riddled with inefficiencies that undermined both quality and resource utilization. The most glaring flaw was its inability to account for video complexity. High-motion content like action scenes or sports required significantly more data to avoid compression artifacts like blockiness and banding, but the static ladder underallocated bandwidth, resulting in degraded visuals during critical moments. Conversely, low-complexity content such as animations or still-frame documentaries was over-encoded, wasting bandwidth with no improvement in quality, which wasted a ton of resources over Netflix's catalog. CBR compounded the issue by assigning the same bitrate to every single frame, treating static shots and explosion-filled sequences identically, leading to either huge overcompression or giant bandwidth waste. Static VBR, while slightly better, couldn't dynamically adjust enough to meet high-complexity demands, leaving fast-paced scenes looking pixelated and subpar. This reliance on static encoding based on generic industry standards like Apple's guidelines meant that Netflix was bleeding billions of dollars, and neither the investors nor the viewers were happy. And then in 2015 came the major breakthrough that would change everything for Netflix and its viewers, by abandoning everything and introducing per-title encoding optimization. Instead of forcing every video into the same rigid framework, Netflix tailored the encoding process to each title's unique visual and temporal demands, setting a new gold standard for efficiency and quality in streaming. Instead of blindly applying a predefined bitrate ladder, Netflix developed a highly analytical process that evaluated the characteristics of each title. By understanding the unique demands of a video, Netflix could optimize both quality and efficiency in a few simple steps. Number 1. Decoding. Netflix's encoding process starts by assessing each frame's spatial complexity, or how detailed each frame is, temporal complexity, or motion levels between frames, and visual noise, or elements like film grain or smoke, using advanced machine learning techniques. High-detail scenes like forests or cityscapes with moving cars, leaves, and animals naturally demand more data than static shots. For example, a stand-up comedy special with minimal movement and a simple backdrop requires only about 1.5 megabits per second at 1080p to maintain quality. In contrast, an action-packed Marvel movie filled with explosions, rapid movements, and intricate CGI effects necessitates a higher bitrate of 8 megabits per second or more at 1080p to preserve visual clarity. This analysis generates a quality bitrate curve for each title, mapping the minimum bitrate required to maintain optimal quality at various resolutions. Using this curve, Netflix dynamically allocates encoding settings and resources according to what's actually needed, instead of applying the same encoding parameters across all content. This dynamic allocation efficiently uses resources, assigning higher bitrates to complex scenes while conserving bandwidth on simpler ones. As a result, Netflix optimizes bandwidth usage without compromising quality, providing consistent viewing experiences across all content and enhancing efficiency in delivering high-quality visuals to viewers. But analyzing complexity is just the beginning. Next comes fine-tuning the quality bitrate balance. Speaking of, thanks so much for all the support on the channel lately. It really means a lot, and I want to give something back to you guys. So do you need a job? That sounded a bit weird. But whether you're a UX designer, app developer, freelancer, or just a curious viewer, I want to get to know you guys, share some UX and UI tips, and maybe even get a gig. So I made a Discord channel for us and want to make this the place to be for front-end professionals. And I'm having talks with people to get some employers in there so you can connect with them come too and find some jobs in the future. I'm really excited to get this thing started, so I hope you'll join me. Number 2. Multi-resolution test encodes. To refine the quality bitrate balance, Netflix encodes each video at multiple resolutions: 480p, 720p, 1080p, and 4K, testing various bitrate levels for each. These trial encodes allow the system to dynamically adjust settings, ensuring each resolution achieves the perfect balance between quality and file size. The goal is to identify the sweet spot, where compressed video appears visually identical to the original content. By analyzing these results, Netflix determines the most efficient encoding parameters for each resolution, ensuring optimal quality while minimizing bandwidth usage. Once these optimal parameters were found, Netflix fed them into what actually made the difference: a bitrate ladder. Number 3. Customizing the adaptive bitrate, or ABR ladder. Netflix uses the data from its analysis phase to create a custom adaptive bitrate, or ABR ladder for each title. Unlike static ladders with uniform bitrates, this dynamic system allocates bitrates based on the content's complexity. For instance, low-motion content like animated comedies can stream in 1080p at just 1.5 megabytes per second, while high-motion content, such as action films, gets higher bitrates to preserve clarity. Through convex hull optimization, Netflix ensures the ladder includes only the most efficient bitrate resolution pairs, discarding options that add little quality improvement. This keeps the ladder streamlined, balancing performance and bandwidth efficiency seamlessly. Number 4. 2-pass variable bitrate, or VBR encoding. With the ladder in place, Netflix takes the process even further by fine-tuning compression through its 2-pass encoding system. Netflix actually employs 2-pass variable bitrate, or VBR, encoding for precise compression. In the first pass, the system analyzes the video frame by frame, gathering detailed statistics on complexity, motion, and texture. The second pass uses this data to allocate bits intelligently, directing more data to high complexity frames while compressing simpler frames more efficiently. This targeted approach ensures that even the most intricate scenes maintain their visual quality without wasting resources on less demanding ones. By optimizing compression at this granular level, Netflix achieves maximum efficiency without introducing visible artifacts, delivering high-quality streams while minimizing bandwidth usage. However, efficient encoding on this scale demands enormous computational power, which Netflix handles with yet another layer of innovation. Number 5. Resource management. To manage the heavy computational demands of encoding, Netflix created an internal spot market system for resource allocation. Encoding tasks are dynamically distributed across underutilized computing resources within Netflix's infrastructure. This system not only ensures efficient use of available capacity, but also delivers significant cost savings, reducing encoding expenses by an impressive 92% compared to traditional dedicated encoding farms. By leveraging this innovative approach, Netflix can efficiently process massive volumes of content while scaling seamlessly to meet the demands of its ever-expanding catalog, all without compromising speed or quality. Here's a real-world example. Traditionally, encoding 1,000 hours of new content each week might require 100 dedicated servers, each costing around $10,000 annually for power, cooling, and maintenance. That's a hefty $1 million per year. With Netflix's innovative system, they cut down to just 8 dedicated servers, bringing the cost down to a mere $80,000 per year. That's a jaw-dropping savings of $920,000 annually per 1,000 hours of new content. But the magic doesn't end with cost savings. This strategy supercharged their scalability. As Netflix's library grows, the encoding workload increases, but their system effortlessly adapts without needing a proportional investment in new hardware. Plus, by maximizing the use of existing resources, they significantly reduce energy consumption and their carbon footprint. It's a win-win-win. Cost efficiency, operational agility, and environmental responsibility. Talk about turning a challenge into an opportunity for innovation. This efficiency stems from Netflix's meticulously engineered encoding process, transforming complexity into scalable precision. Which brings us to the crux of it. What did Netflix achieve with all this? What did these changes actually accomplish? The real truth of Netflix's encoding revolution lies in its tangible results, namely money, efficiency, and scalability. Money was the most important part. For animated content, which inherently has low temporal complexity and relatively simple spatial details, Netflix achieved 1080p streaming at a mere 1.5 megabits per second. For reference, before this system, the same quality would have required 2 to 3 times that bandwidth, depending on the encoding ladder. With complex content like high-motion action sequences, Netflix didn't cut corners either. Instead, they ensured these sequences received the higher bit rates necessary to maintain clarity. The result? For 4K streams, bandwidth usage dropped by an astonishing 50% while preserving or improving visual quality. Let's put that 50% bandwidth reduction into perspective, shall we? That 50% bandwidth reduction is a game changer when you break it down. Before Netflix's encoding overhaul, streaming a 4K movie was like trying to fill a swimming pool with a fire hose. It demanded a hefty 15.6 megabits per second. Over a 2-hour film, that's roughly 14.04 gigabytes of data. Quite hefty. Then Netflix worked their magic. Bam! They slashed the bitrate down to a sleek 7.5 megabits per second. Now that same movie only sips about 6.75 gigabytes of data. That's a savings of 7.29 gigabytes per movie, a staggering 52% reduction. It's like they found a way to pack your suitcase so efficiently that you only need to bring half the luggage, but still have all your outfits. Absolute sorcery, right? Not only did Netflix realize massive savings through this initiative, but its savings meant you and I could take pleasure in buttery smooth 4K streaming without needing ultra-fast internet service providers. They didn't just cut costs, they also helped democratize high-quality streaming, truly turning a problem on its head. The quality improvements were equally groundbreaking. By leveraging its per-title encoding system, Netflix created a level of adaptability that traditional encoding systems could never achieve. High-motion scenes, which often suffer from compression artifacts like blockiness or banding under static encoding, were now handled with such precision that even on slower connections, where traditional streaming would degrade into blurry, pixelated chaos, Netflix's adaptive approach preserved a seamless viewing experience thanks to the efficiency of their ABR ladder and intelligent bitrate adjustments. What makes this even more impressive is the scalability of the solution. Netflix didn't just optimize for viewers with high-speed broadband. They engineered their system to work in regions with limited internet infrastructure, allowing high-quality streaming even in areas with constrained bandwidth. By intelligently managing bitrate and resolution trade-offs, Netflix could deliver watchable streams on connections previously deemed insufficient and across a global content delivery network, each saving cascading down to the next. Less bandwidth means lower peering costs, less load on content delivery nodes, and reduced energy consumption across the board, which made sure that even under peak demand, using their encoding data to prefetch and cache the most efficient streams. And it doesn't stop there. The system's adaptability extended to cloud resource management. By dynamically allocating encoding jobs to underutilized resources in their internal spot market, Netflix slashed encoding costs and created a fail-safe mechanism for handling encoding demand spikes. This resource optimization wasn't just cost-effective, it was a logistical masterpiece that allowed Netflix to scale their operations globally without needing a proportionate increase in physical infrastructure. This ultimately achieves a rare trifecta: reduced costs, improved quality, and expanded accessibility. This isn't just a win for Netflix, it's a redefinition of how streaming can and should be done. And the ripple effects? Those are worth exploring next. How did the system go from an internal innovation to an industry standard? The answer lies in the way Netflix set the bar for everyone else. Remind yourself, while binge-watching in stunning 4K, of all the magical tech behind its creation. Small changes make such a significant impact. It's remarkable to witness. Netflix has worked their marvel, but do you know what else plays a marvelous character right in your home? Your Wi-Fi! Ever wondered how it works? We have an entire video on that.